Hello everyone. In the last lecture, last 5 lectures, we have discussed what is the finite state machine or finite automata, and what are the different kinds of finite automata, specifically DFA and NFA. We have discussed what is DFA and how a problem is given to you and how to construct the DFA considering all the properties. Now, we will discuss the NFA, that is non-deterministic finite acceptor. So, if in case of DFA, we know that it must have to accept or maintain 3 properties, that is all states must consume every element of the alphabet, then after taking an alphabet input, state must transit to a sorry not unique single state. Not more than one state, and DFA accept lambda. So, these 3 properties that DFA must have to maintain, that one first is each state must consume every element of the alphabet that is mentioned for that machine. Next is after taking an alphabet as input, a state must transit to a single state, not more than one state, and DFA will not accept lambda. And in case of NFA, we do not have to maintain any of the properties. That means, in the first property, what is mentioned over here, in case of NFA, a state may consume all the elements of the alphabet or may not consume all the element of the alphabet. And in second property, after taking an alphabet as an input, it can transit to a multiple numbers of states, or it may not transit to any one of the states, and NFA may accept lambda. Now, let us see an example. Suppose Q0 after taking A, it is transiting to Q1 as well as Q2, which is not possible in case of DFA. And again after taking A, it is transiting to Q3, then Q4, and on the other case Q2 after taking A, it is going to Q5, and at Q5 after taking A, it is returned back to Q2 again, and Q4 and Q5 are the final state. Now, tell me, is this an NFA or DFA? Well, it must be NFA. Why? Because after taking an input, it is transiting to multiple number of states, first thing. And second thing, in case of DFA, we already mentioned that each state must consume all the elements of the alphabet. Here the alphabet is only A, but Q4 here does not accept any A. So, it must be an NFA. Now, what should be the language for this machine? The language means we have to find out the state where final state is reached. So, final state is reached at Q4 and Q5. So, at Q4 how many inputs have been consumed? That is 3A. And at Q5, after taking 2A, it reaches to Q5. Again, after 3 and 4A, it again reaches to Q5. Again, after consuming 6A, it is reaching to Q5. That means 2A, 4A, 6A, 8A, 10A. That means whenever the even number of A's are being consumed, it is reaching to Q5. So, can we write it as A twice n, where n greater than equal to 1, means at least 2A it must consume, and after that integral multiple of 2A is required to reach at Q5. So, this one is taking me to the final state, that means 3A, as well as even number of A is also taking me to the final state. So, both are the part of this language. So, can I write this A3 union A twice n, which is the language for this machine? Hope you understand that how we have derived the language out of this NFA. Now, let us take another example. Well, it is also an NFA, right? Why? Because at Q0 we have considered 1, but we have not considered 0. At Q1, after taking 0, it is going to Q0 as well as Q2 also. And another thing is that Q0 is accepting lambda. So, in all cases, it is not maintaining the properties of a DFA, henceforth it is an NFA. Now, in these cases, what type of question may come? If I give another example to you, it may be clearer to you. Now, well, in this example, the question comes as what should be the output of these transition functions Q1A delta star Q2 lambda delta star Q2 AA. Now, what do you mean by delta star? Earlier we have seen that only delta, right? Delta star means in case of delta, single delta, what happens that a single state which will be accepted by a single input alphabet, and it will transit to a particular state. But in case of delta star, instead of a single alphabet, it may consume multiple numbers of alphabets, but it will transit a step after taking a single alphabet only. Means instead of a in gist, what we can write that instead of a single alphabet, it can take multiple numbers of alphabet. Now, why it is how it is applicable in case of an NFA? Suppose in case of Q1A, it is written that where it should go. Now, look at this, directly Q1A is not there, Q1 is accepted by lambda only, and then Q2 is accepted by lambda only, and at Q0 we have A to be consumed. Now, can I write like this one, like this, Q1 lambda lambda A, because we know that adding lambda before A or after A, it remains A only, because lambda is a null string. Now, if I take lambda lambda A, means that Q1 will be directly accepted by lambda, then it will transit to Q2, and then after taking another lambda, it will transit to Q0, and then after taking A, it will transit to Q1. So, directly A is not being accepted by Q1, but instead of this, we can put lambda lambda A wherever it will go to Q1 only. Similarly, for Q2 lambda, we have a direct transition of q 0, right. Now, what happens to delta star q 2 a? Now, in q 2 also we do not have a direct transition path for a, but what we can do that we can put, if we put a lambda before a, that case we can write q 2 lambda a, that case it will come to q 1. Again for q 1 there is no direct path after consuming a, but we have lambda lambda a. Now, can we write lambda a and then lambda lambda a instead of a? Now, we can have a direct transition path. Now, at q 2 if it gets a lambda, it will first reaches to q 0, right, and at q 0 if it takes an a, it reaches to q 1, and at q 1 if it takes a lambda, it reaches to q 2, and at q 2 if it takes another lambda, it reaches to q 0, and at q 0 if it takes an a, it reaches to q 1, means ultimately delta star q 1 q 2 a must be q 1. So, these 3 should be the answer. So, we have to be cautious in case of NFA whether any lambda transition is there or not. If lambda transition is there, then we have to consider that particular alphabet after accepting lambda, before that particular alphabet or after that particular alphabet. Now, I am giving another example. So, in this one is also again an NFA because lambda is there. Now, the question is asked that whether 0 0 will be accepted by this language, 0 0 will be accepted by this language, 4 0 will be accepted by this language, and 0 1 0 0 1 should it be accepted by this language. What do you mean by the acceptance of this string by this language? After accepting this string, if the machine reaches to q 1, which is the final state, then we can say that the string will be accepted by this language. Now, let us start with 0 0. Now, at q 0, if it accepts 0, then it goes to q 1, and after that if it accepts 0, either it will goes to q 2 or it will goes to q 0. So, there is no chance of acceptance by q 0 0. Now, let us consider for 0 0. Now, in case of 0 0, after accepting a 0 by q 0, where it will go? It will go to, it goes to q 1, and then again another 0, it goes to q 0, and another 0, it comes to q 1. That means, this language must be accepted by this machine. Now, in case of 4 0 again will do the same thing that happens in case of 0 0. That means, after taking 4 0, it must comes to q 0. So, it will not be, it should not be accepted by this machine. Now, what about 0 1 0 0 1? Now, in case of 0 1 0 0 1, so after taking a 0, it must comes to q 1, then 1, either it may be in q 1 or it may goes to q 0. So, if I consider q 1 first, then it will be in q 1, and after that 2 0, it comes to q 1, and after that 1 1, then it comes to q 1. So, this one must be accepted by this language. So, we have to consider all the possible situation, and if any one of the situation it reaches to final state, then we can say that that machine will be accepted by this language. Now, let us consider a few more tricky questions. Draw an NFA that accepts AB, ABC whole star. What do you mean by that? That star means multiple occurrence of AB is possible, multiple occurrence of ABC is also possible, and no occurrence of AB or neither ABC is also possible, and the combination of AB and ABC multiple number of times is possible. Means that AB is possible, ABC is also possible, then ABC multiple combination is also possible, and lambda is also possible, right? Now, as it is an NFA, easily we can solve this problem like this. Take AB, it goes to one path, and we have to consider that as lambda is also acceptable, that means Q0 must be the final state. Okay. Now Q2, now as multiple combinations of AB is possible, what we can do, that we can return back to Q0 with a lambda, that means which consists of multiple occurrence of AB. Now for multiple occurrence of ABC, we will do the same thing, comes to Q3, then B, it comes to Q4, then C, Q5, and whenever we do not require any ABC combination, then we will come back to Q0. So this one confirms me multiple occurrence of AB, this one confirms me multiple occurrence of ABC, and if I want to take the combination of AB and ABC, I can take the path of AB or ABC as per my wish. So this can be considered as the NFA for this problem. Now the next question that is asked, that is it possible to draw this NFA with 3 states? Is it possible? Now let us see. So if we do the same thing, Q0 is my final state, take A, it goes to Q1, then B, it goes to Q2, and if I require only AB, multiple occurrence of AB, that case after taking lambda it will return back to Q0, and instead of this, if I want the multiple occurrence of ABC, that case I will take only C, and it will optimize the number of states. Instead of 5 states, we can reduce it to 3 states. So that is also possible in case of NFA. Now the next question is it possible to reduce it less than 3 states? Answer is no, because we have minimum number of available string is ABC. That means if I have to consider ABC, that case minimum 3 states are required to consume this A, B and C. So less than 3 states, it is not possible to consume ABC. If I consider that one alphabet will be consumed in each state. Okay. So coming back to another problem. Draw an NFA that accepts A star if a single edge is removed without making any other changes, then the NFA will accept A only. So for the first portion, for this portion, the answer is very simple. Just draw Q0 A, and it confirms that multiple occurrence of A or no occurrence of A itself. Now the next question is, if we remove a single edge from this NFA, then it will accept only A. Now first draw, you have to draw, in this case there is no restriction of number of states. So what we will do, that we will draw two NFA and combine them. One will accept A star, another will accept A. Another is Q2, that is also final state accepting A. Now how to transit from Q0 to Q2? Using lambda. So I have two different machines, one which will accept A and goes to final state, that is also a part of Q2, and another is A star. Now if I remove any one of the edge, which edge to be removed? If I remove this edge, then this machine will accept A only. Hope you have understood. Now why non-determinism? Why we have to do NFA? And first question. Another question is, which one is more powerful, NFA or DFA? Expression wise, both have the same expressive power, but in that case the next question will come, why we need the non-deterministic finite automata? Well, these cases we have to come back to a small story. Suppose consider a situation where all you have 4 or 5 friends who has lost the path in a jungle. Now you have to find out the main road through which you can escape. Now what you are doing, that you told everybody to try to find out the path. You take a chalk, so that after, if you find out the main road, then you have to return back to a single point, so that everybody can escape through this path. Now after 2 hours, one of your friend return back that I got the road. After half an hour, another friend come and he told that I find out the road. Another person which has returned back after 1 hour. So one person found the path after half an hour, another person found the path after 1 hour, another person found the path after 2 hours. Now which path you will choose? The shortest path, obviously the shortest path, that is the friend which has found the path after half an hour, right? So same things can also be happened in case of NFA. NFA means I know my goal, I know my path, but I don't know how to reach the path. In that case, we will use all possible combinations to reach the path, and after that, which one is the shortest one, using all rules of DFA, we will use that path, and which is the DFA. That means for a particular problems, there may be multiple numbers of NFA, but there will be only one DFA, which is the shortest one with all the rules that should be maintained by a machine. Now if a problems, similarly, if a problems of a machine is given to you and you are asked to find out the DFA, but you don't know how to find out the path, and you are not sure it's about that whether this path is the optimum path or not, that case what will you do? You will first try to make the NFA based on the requirement of that machine, and after that convert that NFA to DFA. So there is a certain procedures through which we can convert an NFA to a DFA. In the next lecture we will discuss that how to convert an NFA to a DFA.